I'll take questions from anything from the entire semester, but we'll probably want to focus on the review because that is where your exam comes from. So do you have any questions?
Number 4?
Number 4, number 11. We'll go in order. We'll do 4 first, then 11. How's that? Trig substitution. Okay, so 0 to the square root of 2 over 2. X squared. Square root 1 minus x squared dx. All right, I will provide you the triangles, you know what I'm talking about, for the trig substitutions. I will provide those for you on the exam. For this one, Ernie, can you see over here okay?
Yes.
For this one, we're going to want to let the hypotenuse be the 1, opposite side x, and this side will be square root 1 minus x squared. Now, when I put 1 on that hypotenuse, that's actually the square root of 1. So like if that was a 9 there, we'd be putting 3 there, the square root of 9.
Is that like a square?
Yeah, that's like c squared is what it is. A squared plus b squared equals c squared.
Oh.
So we would be putting the square root of whatever this value is there. All right, so with this arrangement, we have sine theta equals x over 1. So x simply equals sine theta. And dx will be cosine theta d theta. Are you guys okay with that? All right, I'll move over here. We'll adjust the bounds in a moment, but let's put this stuff in. So x is sine theta, so x squared will be sine squared theta. We have 1 minus x squared inside the root. So that'll be 1 minus sine squared theta. And we have dx, and dx is cosine theta d theta. Oops. Now, it's possible that you would get one where, you know, this is something like a 9, and this is 9x squared. Okay, you got to be aware of that. And in that case, this would be, if that was a 9x squared, the square root of that would be 3x. That would be a 3x. And there would be a 3x here, and you'd have to carry that number through the problem. It would also show up in the dx. We got a 1 there, so it's all 1s, and we don't see it. All right, from our bounds. So 0 to root 2 over 2, that's in terms of x. If we put that into x here, we would get, so bounds, we would get sine theta equals root 2 over 2. Well, sine of what angle is root 2 over 2? Look on the unit circle, and you would get pi over 4. So our upper bound can be pi over 4 when we're in terms of theta. 0, so sine theta equals 0. I'm just putting 0 in for x here. Sine theta equals 0. Sine of what is 0? Sine of 0 is 0. So our lower bound would be 0. All right. All right, let's clean this up. 1 minus sine squared. What's 1 minus sine squared? Pythagorean identity. Cosine squared. Sine squared plus cosine squared is 1. So if you subtract sine squared from each side, you'll get cosine squared equals 1 minus sine squared. I'm showing lots of detail. Square root of cosine squared is cosine. And now those cosines divide out. And we have sine squared theta d theta. Now on the integral sheet, you have a formula there for sine squared. It's at toward the bottom. And I'm forgetting if it's plus or minus in between. Is it 1? It's minus. So if it's minus, then the antiderivative of this is theta over 2 minus sine 2 theta over 4. All right. Now at this point, we could rewrite it in terms of x. So we'd have to change sine 2 theta. We're going to change that anyway. So sine 2 theta is like, there's a trig identity on your sheet where all the trig stuff is. That is 2 sine theta cosine theta. That's sine 2 theta. And then 2 divides that 4, so we would have sine theta cosine theta over 2.
2 divided by 4.
So I kind of skipped a. Imagine this sine 2 theta being replaced with 2 sine theta cosine theta. That 2 would reduce with that 4. 2 goes into 4 twice.
Oh, 1/2. That's okay.
Yeah. And then I left that off. All right, now let's plug in our bounds. So we're going to have pi over 4 over 2 minus sine pi over 4 cosine pi over 4 over 2. If we put 0 in here, 0 over 2 will be 0. If we put 0 in here, sine of 0 is 0, times all the rest of this would be 0. So when we put in 0, we're just going to get 0. Pi over 4 over 2 is pi over 8. Sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. So that'll be 2/4 over 2. Root 2 times root 2 is 2. 2 times 2 is 4. And that will reduce to 1/4. Let's try it. I think that's it. Go.
So was I using that one sheet with the triangles?
Hold on, I lost my line. tried to grab that pen with my foot and I wiggled the wire.
Oh, the monitor
Might be
one.
done with the monitor. I don't know, I barely bumped it.
It's
Is
not
it pulled here?
behind it, maybe it just. Interesting.
It was down here, so I think it pulled something up here.
Oh, so that's what it.
Try this again, just in case. Power saving mode.
You have to change it to 2 sine cosine theta.
Do you have to? No.
You just did that because you wanted to cancel out with the 4?
Yeah, we could have put pi over 4 in right there. And then 2 times pi over 4 would be pi over 2, and sine of pi over 2 would be 1. And we would still get the 1/4.
Like mine has
Does that make
60. Mine has 64 instead of that 1. So I just kind of just carry it over, just keep it going.
Then you had 64x squared?
Oh yeah.
Yeah.
Mine is X. So it would be a square. Oh, I mean, it would be 8, I guess, if you take away the 8
So you had,
minus. But I didn't even know about the.
you had this?
No, it would have been just minus X squared. 64 minus X squared.
You had to have something on both, I think.
X squared on top, and then divided by the square root of 64 minus X squared dx.
Just x squared?
64 X squared. Yeah, because then it's like you treat the 64 like a squared minus X squared, and it makes sense according to that triangle.
Well, what you should be able to do is something like this. And then pull the 64 out here and it becomes an 8.
Oh, I see. Okay.
And then you gotta keep this 8 carrying through the whole problem.
Ah, that's how you do
That
it.
makes
All
sense?
right, yeah.
That's what you should be able to do.
They were like how Ernie said.
Say again?
They were how Ernie said, they were just 64 minus x squared.
64 minus x squared.
Yeah, I didn't have anything attached to x squared.
Okay. Well, in that case then, this would be 8 square root of 64,
Yeah.
okay? And that would still be x, and this would be 64 here. And sine theta would be x over 8. So x would equal 8 sine theta. I see it now. Yeah, you're right. That's how it was. Because now when you plug this in, you'll get the 64. Yeah, you're right.
Mm.
You see that? So you would have, when you get to this step, you would have 64 minus 64 sine squared theta.
Perfect.
When you get to that step. Then you could factor the 64 out, which when you take it out of the root, it would become 8 here. And it would carry through the problem. Is that okay, Ernie?
Yeah.
All right. All right, let me get back into Pearson.